Hey everyone, I'm Tom from Mortons on the Move, and today you're watching our RV security and safety series. In this video, we're going to be talking about RV electrical safety. Now, this is not a how RV electrical systems work video, but I do need to talk about the basic RV electrical systems so that you can follow along a little better. RVs have more than one electrical system. Unlike in a house that you have one primary 120 volt electrical system, RVs typically have at least two systems, sometimes up to 4 or even 5. The first system in the RV is the 120 volt electrical system, and that is what lights up the plugs that look just like the ones in your house, and it's what lights up when you plug the RV into shore power or plug it into that pedestal at the campground. The next system in the RV is a 12 or sometimes 24 volt DC system that is mediated by a set of batteries so that when the RV is unplugged, it will continue to operate. This system runs things like lights, a water pump, and other appliances that you don't want to shut off like the furnace when you are unplugged. Those are the two primary types of systems that you'll find in an RV, but sometimes you'll find additional systems like a 12 or 24 volt DC engine and drivetrain system in a motorhome that is self-propelled, a 120 volt generator that can be built in or portable like this one here, and sometimes you'll also find inverted systems, usually included with a solar system, which is yet another type of system that operates at the solar panel voltages, or inverters that convert the battery 12 or 24 volt into 120 volt AC, like this portable inverter here, or a hardwired one like we have right here. So all of those systems have some hazards of their own, and let's walk through each one of them and talk about some of the things that you need to consider when dealing with your electrical system to stay safe. Starting with plugging the RV into shore power, especially when you're plugging into a circuit that you are unfamiliar with, like at a campground or something, the first thing I usually recommend is to get one of these little outlet testers. It just has a couple LEDs on it and a little list of indications of what the different LEDs mean when they light up. You can plug this into the 20 amp circuit on the pedestal that should be there by code in the US and turn it on. You're going to look at those LEDs and see if there's anything wrong with the circuit. It should tell you if there is an open ground, open neutral, or something else wrong with the circuit so that you know ahead of time before you even plug your RV in if there might be a problem. If everything looks okay with that, go ahead and plug your RV in. But first, make sure that the breaker is off at the box. With the breaker off, take your big plug, in this case a 50 amp, or it might look something like that, a 30 amp plug, and make sure your fingers are not touching any of the prongs, and plug it in with one hand facing away from the box. The reason that we plug it in with one hand is that if there's something wrong with the plug or you accidentally touch one of these prongs, if you have your other hand touching the box, you're giving the current a really great path to flow right through your heart, which is the most dangerous way to get shocked and increases your likelihood of an electrocution. If the breaker is off, it shouldn't be a problem, but it's still good practice to plug it in with one hand. Next, make sure that the RV doesn't have any loads on inside it and go ahead and flip that breaker on. But again, flip it with only one hand. It's usually recommended to flip it with the left hand facing away from the box. Just like plugging it in, making sure that you do not have your other hand touching anything that the current could flow across is good practice to eliminate the chance that the electricity could flow across your heart if there was something wrong with the breaker or it possibly electrified the actual panel itself when you turn the breaker on. Another thing that you can do to make sure that the circuit is actually wired right is consider using a surge protection device. These are devices that you can plug in or sometimes actually hardwire into the RV, and they're going to actually look at the circuit and make sure that there's nothing wrong with it as well, similar to what this device does. Once you turn that breaker on, it will analyze the circuit and make sure everything is wired right, and also protect from under and over voltage circumstances and possibly surges. Since you're plugging into an unfamiliar source, these are actually really good options. And if it detects that anything's wrong, it's a great idea to let the park or manager, whoever it is that owns the system, know, because If it's wrong at your pedestal, it could actually be wrong at other people's pedestals as well, and could be causing a dangerous situation for those other RVs. Once you get the RV plugged in, a lot of times you're probably going to be using things that look like this. They usually call them a dog bone adapter that's changing, in this case, 30 amp service down to a 20 amp service. And you're going to want to make sure that any of these are not left out in the rain, or especially not in a puddle of water. If possible, elevate them off the ground, even if they're out in the rain, and covering them is best practice as well. If you are using some of these adapters to get a longer distance or plug into a different circuit, you also want to make sure that you're running the appropriate wire size. If you have 50 amp service and you have a big heavy cord like this, you're plugging directly from the RV into the 50 amp service, the cord should be rated to carry the entire 50 amps just fine. The 30 amp cord is considerably smaller, but again, should be rated to carry the full 30 amps. If you use something like this that is a 30 amp down to 20 amp adapter, this allows us to plug our 20 amp extension cord into a 30 amp breaker. And we have this in case we need to run a really long way to a 30 amp outlet. We could potentially pull more current than this wire is rated for on this circuit. The breaker will not protect the wire, so you need to make sure that you're not drawing more power than your wire is rated for. This could overheat the wire, burn the outlet box, or even cause a fire. You also want to consider voltage drop. If you're using a really long run, you can't run 400 feet to a 20 amp service with just an extension cord like this. You're going to get a significant voltage drop and could damage your RV or the wire itself. Once the RV is plugged in, it's also a good idea to take this tester and test a handful of the outlets inside your RV to make sure that there's no reverse polarity, open ground, or any issues like that in the RV on the 30 or 50 amp plug. Once you get the breaker on and the RV is fired up, the breaker out at the pedestal is the primary form of protection for the RV. If you draw too much current, you have too many air conditioners on and electrical devices, that breaker outside will pop and it's going to protect the cable and the entire RV. Inside your RV, however, you have a sub panel that includes a handful of breakers, and these are smaller amperage breakers, 15 and 20 amp breakers that are going to protect each individual circuit inside the RV. If one of these breakers trips, you don't want to continue to reset it if it continues to trip unless you know what the cause was. This goes for a house as well. If you continue to reset a breaker that keeps tripping and you don't know what the cause is, there's something wrong with it and it could be a dangerous situation. Now, getting a little bit more technical here, actual RV wiring. This is an important fact for RV wiring. RVs should not have the neutral conductor of the AC circuit bonded to the ground in the panel. In here you'll see this is our neutral bar, so we have power coming into the breakers themselves, and then neutral is where the power makes its way to. In a household, this needs to be bonded to the ground so that there is a path for the current to flow back to if something is shorted to ground. In an RV, you do not want that bonded here at the panel. The reason for this is that if there were a reverse polarity on the circuit, meaning that the neutral and hot were somehow flipped, and the testers that we talked about earlier, the surge protector or the circuit tester, should easily tell you if that is the case. But if it's somehow missed and there is a reverse polarity, if your neutral is bonded to your ground, what that's going to do is it's going to make the neutral hot, which the ground will be at the same potential, and the frame of the RV will become 120 volts to ground. That's of course dangerous because you could just reach up to grab your handle to open your RV and get a shock. Most newer RVs are done properly like this, but I have seen a lot of electrical mistakes from manufacturers, and bonding the neutral and the ground is one that you definitely want to make sure is not done. So with any 120 volt system, like in a house, the rest of the rules still apply. Don't stick things in the plugs, don't use appliances around water, and just be careful because the 120 volts is enough to push enough current across your heart to cause electrocution and possibly death. So definitely be careful with the 120 volt system. It's probably the most dangerous system in the RV. So when your 120 volt system is plugged in, most of the time it is going to be charging the 12 volt system or providing the 12 volt power. And that's going to provide things for our lights and the rest of the RV. And in this compartment here, you can see that over here we have the 12 volt system. We have positive coming from the battery and a negative bar here. And instead of breakers, you have fuses. And the fuses for your 12 volt system, you want to make sure that they are sized appropriately. There should be a list of fuse sizes for each circuit, and you want to make sure that you're not oversizing them on the circuit. Here we have a couple of 3 and even 1 amp fuses. If I were to take a 20 amp fuse and put it in there, we could provide way too much current to that circuit. And what those are designed for is that if there's a short or something wrong with the circuit, that they're going to protect the circuit. If you're putting the wrong size fuses in here, you could damage the circuit or even cause a fire hazard. 12 or 24 volt systems are touch safe. I can go ahead and touch these terminals and there will not be any shock hazard, so that is definitely a benefit to the system. But the batteries can still provide a lot of current. If we were accidentally short this and this together, we would see a big spark and could potentially even melt these wires. Although we do have a big fuse back at the battery that should protect this circuit, all RVs should have at least some sort of protection back at the batteries and also a way to shut the batteries off. So in our coach, we currently have lead acid batteries, and the batteries themselves can be quite dangerous. When charging, these batteries put off caustic fumes. In here you can actually see some corrosion. These are in their own separate compartment and they have this rubber gasket to keep those fumes from getting into the rest of the RV. You definitely don't want these in living space, and you want them properly ventilated because those fumes also are potentially explosive. When charged, these batteries also have a very strong acid in them, and a lot of times, especially with 6 volt batteries, you can actually access that acid through these ports on the top, so you want to be really careful when dealing with the batteries themselves. Also, these batteries can put out a lot of current. If we were to accidentally short between these 2 points here, there is no protection between this. If you were to put a wrench on this to tighten this down and accidentally touch the other terminal over here, you could actually melt the wrench. We've seen wrenches completely bend and melt, and it could also cause a fire. You should also have a proper battery charging system. If these batteries get overcharged and the electrolyte, the acid inside, gets too low, they can actually dry out and catch fire. With proper care and maintenance, batteries can be pretty safe in your RV, even different types of batteries like lithium ion. Lithium-ion batteries are a new technology. They pack a lot more punch for their size, but they need to be properly managed as well. You need to make sure to have battery management system on them and make sure that they are not overheating or even getting too cold. In our case here, we have a battery monitor system that is actually monitoring the current in and out of the batteries and the battery temperature down to the batteries themselves. With your batteries, you also need to make sure to have a disconnect so that when you have to disconnect any of these terminals, they could potentially still be hot, and if they were to contact the frame, if we were to touch the positive to the frame, again, you can cause a huge short and a potential fire hazard. So you need to have a switch that you can turn the batteries off. In our case, it's up here in another panel. So the 120 and 12 or 24 volt systems in your RV are the two primary systems that you're actually using the power from. All the other systems just provide additional power to those systems. The first source of energy is generators, and in our case we like to use a portable generator that we just plug the entire RV directly into. A lot of RVs have a built-in generator, however, and the biggest concern with generators is usually not the electricity, it is the carbon monoxide they are producing because they are burning gasoline or diesel. With a portable generator, make sure to keep it away from your RV so that it does not blow those fumes back into any open windows. And if the wind is just wrong with a built-in one, again, the fumes could possibly make it back into the RV. This is why it is essential to have a carbon monoxide detector and never run the generator when you're sleeping. Now, a generator should be wired correctly at the plugs, but remember that neutral ground bonding thing we talked about earlier at the panel? When you have a generator hooked up, it's a good idea to have that neutral and ground bonded. When plugged into shore power, you're relying on a neutral ground bond back at a transformer somewhere on the primary system. But when your generator is hooked up, there is no neutral ground bond. So that means that that ground conductor, the one right here on the plug, is not going to do anything if there is a short to ground. This is here for protection if something does short to ground, and that is why it's a great idea to bond the neutral and the ground when you are plugged into a generator. Built-in generators typically have this bond already installed in the system, but these small inverter generators, especially like this little Honda, do not have that neutral and ground bonded together. That's why I highly recommend using something like a neutral ground bond plug that you just plug in, and it will provide that protection for you. I will put a later video together about how to create one of these. This is sort of a point of contention around a lot of people, but I firmly believe that this is an important safety feature when running a floating neutral ground system like this. When running generators, the same rules apply as with the 120 volt shore power system. It can still provide shock hazards. You want to make sure that the cords aren't run in the rain, and you want to make sure that everything is in proper working order. Now, it may not be adding power to the system, but a lot of times you're going to be using an inverter to take power from the 12 or 24 volt system and turn it into 120 volt power that you can use at the outlets. This can be done with a simple portable inverter like this that you can plug into the battery terminals, or with something designed to really run the entire RV like this that is designed to be hardwired into the system. Like generators, it is recommended to bond the neutral and the ground with these. Again, this is a floating bond, so I can use my neutral bond ground plug and just plug it right into one of these and provide that protection. If you're plugging it directly into an inverter like this, a lot of times you're not actually going to have any ground on this system at all, so this isn't really going to do you anything. But if you're going to wire your entire RV into an inverter, it's a great idea to have a means to actually connect that neutral and ground. In this right here, it actually has a relay that will automatically close and do that as part of the safety feature built right into it. When running an inverter, these things can potentially get hot, so you want to make sure that they have adequate ventilation around them, and also you want to provide them adequate power. They can draw a lot of current from your battery, so you need to make sure that your wires are sized properly, otherwise they can heat up, burn up, and potentially cause a fire. If you're using a portable inverter like this, you want to be really careful when you're attaching this to terminals so that you don't accidentally touch these together when you're connecting them. They should be far enough apart, but it is possible that they might touch. This is very similar to using jumper cables with a car. You want to make sure that you connect them and you have the other ends spread far apart, because if you connect these, you can provide hundreds of amps that could easily melt these cables and potentially damage, burn you, or catch fire. Another common type of system in an RV is a solar system, and these have some concerns of their own because you can't turn off the panels when the sun is shining. If you have a solar system installed, you need to make sure to have some sort of a disconnect switch so that you can disconnect the panels from the charge controller and isolate that power so you don't have power flowing to the batteries all the time if you need to work on the batteries. Even if you have a disconnect down at the batteries, however, you're still going to have power on the wires coming from the solar panels anytime the sun is shining. So you need to be aware that there could potentially be a voltage on those wires. Most PV systems on RVs are usually 12 volt systems, but in a case like ours where we're using a grid panel system, you could be running much higher voltages, well over 50 volts, which is considered touch safe. Because that voltage is always present on the system, especially up on the roof, I highly recommend using the standard MC4 connectors for solar panels so that if you need to disconnect the panel, you can do so easily without exposing yourself to any shock hazard. When you do that, you want to make sure that you have disconnected the load on the RV, or if you can, cover the panels so that there is no load when you make these disconnections and potentially cause any arc flash inside these connectors. Because RVs have so many sources of power, the generators, the inverters, the solar, the shore power, if you need to work on anything in the RV, you need to make sure that all of these are disconnected so that there is no potential for a short current or a shock hazard when you're working on it. You also need to understand what wires are hot when in your RV. The solar wires could be hot all the time. The shore power is of course going to be hot only when plugged in, but the generator and the inverters might also be on as well. You need to be aware of your electrical system as well, because as you drive down the road, wires can wear, things can go wrong, and you may plug it in next time you get somewhere and find that you have a problem. So you need to be aware of it. If you ever feel a shock off the frame of your RV, disconnect the RV, alert whoever it is that you're plugged into, campground, or even if it's your home house system, make sure that there's nothing wrong with the system, and then see if there's something wrong with the RV on any of the circuits where you're getting a ground fault. In our travels, we have come across a handful of electrical systems that did have problems. One we were plugged into and it worked just fine until we got a whole lot of rain. There was a ground fault on their system that was elevating the potential of the ground across the entire system. So our RV was getting hot even though we didn't have a neutral bonding issue or anything like that. Because of that, I felt a tingle when I touched the RV and I clearly knew something was wrong. If you were to get a big enough shock, it could potentially cause cardiac arrest, and the first thing that needs to be performed is CPR to try to get that person's heart beating again. Of course, if somebody gets shocked and passes out, you also need to call 911 immediately. Now, there is a lot to RV electrical. I recommend that you become familiar with your system and approximately how it works so that you can understand it. But if you're not comfortable with doing any work on your electrical system, please hire someone that's professionally trained to work on your electrical system. Improper electrical wiring can result in shock, electrocution, or even fires. So definitely let somebody trained handle the electrical if you are uncomfortable with it. This has been our overview of RV electrical safety. We hope this helps you stay safe in your RV. Thank you for watching our RV security and safety series. You can check out some of our other videos in our RV safety and security playlist.